So the rainfall anomalies actually are a deviation of rainfall from a long run averages. So they are very useful for identifying wet and dry periods, which can be linked to climatically influenced patterns such as flood, river flow, and agricultural production. So as you can see from the description, from the background information provided, that's one of the most useful, the usage of having rainfall anomaly with Earth observation data. So this data set, the data product that you're actually going to use will be the rainfall chiefs monthly data sets that we have. Within the description, we actually provide how the rainfall anomaly was actually calculated. So looking at the description, you see that is the X, which is the seasonal mean, the month that you want to determine the anomaly, and the M is the long-term mean for the area, and we have the S, which is the standardized deviation. So at the end of the day, the product that you are going to get is going to be the standardized anomaly, standardized rainfall anomaly for the area of interest that you are working with. With the notebook, currently it works at the country level, but you can actually go down to actually a lower level, maybe a district or a community level, depending on the area of interest that you have. But with the one that you've provided, it actually works at the country level. So any country that you want to work with, you can actually put it there, then the system will be able to do the calculation for you. Within the tutorials, you are going to work, you will be looking at 3 different countries, that's Ghana, Kenya, and Niger. Then after that, if you have any other country that you'll be happy for us to also run it there, you can tell us, then you can run it here. But at your own end, you can also go into the sandbox and locate that particular notebook. The notebook can be located when you log on to the sandbox. Once you go into the real world folder, you see that you have the rainfall anomaly chips notebook available. So it's within the real world examples. Then once you go into the real world examples, you notice the rainfall anomaly chips notebook available. Once you see the notebook, the good way to use it is to right click on it and duplicate it. Otherwise, if you make any changes and the notebook is being refreshed, all the changes that you have will override. So it's always good to duplicate the data sets that we have. Back to the notebook. So because it's at the country level, you specify the name of the country here. So the name of the country here is Ghana. Then the next one is to identify my climatology range, because to do any anomaly test, you have to identify the climatology range. And with this one, you are going to use a 30-year period, which is actually in the standard. So from this notebook, we chose 1981 and 2015 as our baseline. You can actually change this time period also for your baseline. You can go for 1985 to 2015. The base period is not actually something that has to be rigid, but it will be flexible. So you can actually change the base period that you want to use at this particular area. Then the time period also for the anomaly, because you want to do it monthly, we will also do the monthly anomaly from 1981 to 2021 to give us a sense of how wet or dry the area was. The image that we are using, that's the chief data has a spatial resolution of 5 by 5 kilometers. That's why we specify the resolution to be 5,000 by 5,000. Then the dash chunk was also provided to enable it to work faster. The next steps actually loads the GeoJSON data sets, and it lists the countries data sets that we have. So the name that I actually specified here, which was Ghana, was actually picked from these data sets that you see here. So if you are interested in another country like Guinea-Bissau, you can actually copy it from here using your Control-C. Then when you come to the country section, you can right click it and paste it there. So you can copy it, Tracy. And once you come here, you can paste it there. So you are going to get the Guinea-Bissau also at this area. That means that's the country where this is the country where you want to actually load do the rainfall anomaly for. After specifying it, the next cell actually what it does is it helps us to load the GeoJSON data that we've imported into a standard form which the notebook will be able to interpret it. So we have to convert it from either the shapefile or the GeoJSON to a data which the system will be able to understand, which is the geometry that we've done here. Then we set up all these parameters for it. So once we provide all these parameters, the rainfall, the chief rainfall data will be uploaded for us. Because it's loaded for the whole of the African continent, you have to mask it out. And this is where the country shapefile that you specify will be of importance. So it's going to shape it out for us. Then at the end of the day, you only get the country that you want to work with. With this one, the country is Ghana, so you're only going to get that country. Then you would also calculate the standard deviation and the mean for the climatology range that we wanted to work with. So you're going to have the climatology rainfall and we plot it out. So this is for the climatology rainfall that we have. The next one that you have to do is also load the monthly anomaly, because the function for us you want to calculate the anomaly monthly. So you want to do it for the area of interest divided by the climatology. You also have to load the whole year, the months that you want to work with. Then after loading all the data sets, the next step, which you see here, is going to do the calculation for us, whereby it's going to pick individual months. So the individual months for individual months minus the climatology mean, then you divide it by the standard deviation for the climatology. And this one will give us the standard rainfall anomaly for every year. After getting it, what this cell will do, that it will plot it out for us. So within this year, the blue ones are areas that are more wet, and the below ones are the months that had a lot of dry period. So as you can see, between 1990 and between 1992, we realized that we experienced a really great wet period as compared to the other months. And also for the dry season, notice that before 1985, there was also a series of dry period happening within those areas. So the climatology actually help us to actually identify these areas. If you want to see how you want to see the standardized anomaly for everyone, for other months, we've actually also provided a section here whereby you can actually select the year, that's the range of the months that you want to see. So what we have here is 2020 August to 2021 July. No, 2020 July to 2021 June. So as you can see, the climatology areas are being plotted here for you to see. So this is the new notebook that we actually added it to the sandbox for you to be able to have access to. It's available at the real world rainfall datasets. All information you see here, if you want to do it for a particular country, you just change it, you just change the country name here. And when you go to the kernel, restart and run out, please for Guinea-Bissau, it's going to run it for the whole country. And at the end of the day, you'll be able to get the standardized rainfall anomaly for that particular country. So whilst I'm running on the Guinea-Bissau on, we can move on to this is for Kenya. So I just changed the name for the Kenya here. Then the climatology range, I still maintain the 1981 to 2011, right? That's the 30 years. But you can also change it if you want to do it from 1990 to 2020. You can do it based on the information you want to get. Then the time period for the monthly climatology, so you can change it. You can actually do it from 2000 to 2021. All these areas, you are allowed to change it, or you can manipulate it in a way that will suit the work you are doing. Then you still load the countries, as you can see. Then load the rainfall data. So this is actually for Kenya. Okay, it's still running. So so this is actually for Kenya. So it will still run it and process it at the area whereby you'll be able to get the plot as you saw in the previous, area for Ghana that we just did, and what we just ran it for the area. So this is also for Niger that I also started running it. Let's see where it also raised. So this is the region for Niger. So this is for the whole region of Niger. Oh, okay. Let me restart the kernel. Let me run it all again. Sorry. Okay. So those other areas will be run for those other regions. So you can go into the real world folder, check the rainfall anomaly chips, then upload it for the area. Then you'll be able to use the notebook, which is actually a great notebook to work with for the areas that you want to work at. So this is the one for the Guinea-Bissau. As you can see, you've been able to run it for the whole and the chart has actually been able to plot the standardized rainfall anomalies for Guinea-Bissau, as you can see here. Then you do it for that. So you get the time series, you get the chart series for those particular areas. So this is a new notebook that we wanted to share it with you, and we will be happy for you to go inside it and try it at different various, not only at the country level, but you can also try it at the district level, even the community level. You can even go beyond that. But if you are using a bigger area, you also have to be cautious of the memory. If you have access to a large instance, then you can actually go for that bigger area. But if your instance, sometimes if the instance won't allow you to, that means you have to reduce the area to be able to accommodate which area you are going to work with. So that's what I wanted to share with the team this week, and I'm happy to have questions. Thank you, everyone. Okay. Yeah, so please, if you have any questions, I'm happy to answer them.
I asked mine in the chat, Edward.
Okay, is it possible to do the same calculation at the regional level like West Africa? Yes, Baku. I think you can share the shapefile with me, then I'll be able to run it for the whole of West Africa. I think it will involve a huge instance, but you'll be able to execute it.
Okay, thank you.
Yeah, but do you have because you also have access to the large instance, you can also run it at your end.
Yeah, I'm trying to.
Yeah. So all that you have to do is once you upload the shapefile onto the sandbox, at this particular cell 5, you just point it to the area where your shapefile resides. So once you point it to that, once you point the area to that shapefile, then you comment this side out because you are not using that particular region. Then you also comment this area also out. So once you point your shapefile to that particular area, comment the cell 6 out, and also when you come to the cell 7, comment the first line out. So once you're able to do that, you'll be able to and change the IDX here to 0 because you are using one shapefile. change the IDX here to 0. So once you do that, you'll be able to run the shapefile at your own end.
Thank you.
Welcome back.
Yes, I have a question, maybe a comment.
Yes, please.
Yes, thank you very much for this presentation, Edward. I think it's something that one would like to do for, especially for Botswana, because we know Pula is a rare thing. So this the rainfall data set that we are using, is it the same as the one collected by the meteorological organizations in the country?
So we are using the CHIPS data sets, the Climate Hazard Group infrared precipitation with station data. That's the one we are using. So that
is it the one from TRIM, the satellite based, or is it from the observations from meteorological station? That's what I want to know in the countries.
Oh, okay. For that one, I have to check. Yeah, I have to check what the chips that you are using. So once you click on the product you use, it will actually open the information on the chips information that we are using. So the Rainfall chips data set that you are using. So this one is estimated from rain gauge and satellite observation.
No, that's fine. So it's using both the satellite and the in situ measurements.
Yep.
I wanted to just for quality check, so it's okay.
Okay, then. So once you click on the product use, the information on the product will actually pop up for you to know that. Thank you. I've changed the name to Botswana. Let's run at that area and see what will happen. Okay, so it's running. That's created 3x3. So with a dash chain, you can also tend to go by 1,000 by 1,000 or 2,000 by 2,000. You don't actually have to stick by 500. So the number of data you should load at a time, you can stick to those ones also. Okay, so it's loading. Okay. No information on Botswana. Okay.
There's no information. Oh, it's still loading.
Okay, so this was some selected months. This let's see, it's still loading.
I think you probably don't have the information. I don't know. That's why I wanted to know if it's from meteorological organizations, because you know our meteorological stations in Botswana are very preserved when it comes to sharing the data.
Yes, yes. Then the reserve is showing up here. Wow. Okay, let me try
let's hope maybe it's still loading. I don't know, but we always face difficulties when we want to access the data sets.
Oh, okay. Okay. I'll also look into it why there's no data loading for Botswana for the chips later on. Okay, so when I'm also loading it for Chad, let's see what happens. Okay, but probably it will also be my sandbox. But please feel free and try it at your end. Just pick any country that you want to work with, change the name here, then rerun it, then you get the results. If you encounter any challenge, kindly reach out to us, either Joseph, Ken, or I, then we'll be there to support you. So thank you, everyone. Thank you very much.